So if you're familiar with another imperative object-oriented language, we can basically start by just explaining the deltas to this one. And I'm sort of going to discuss, I'm going to break this into three parts. I had the 8 steps to X-ray a new language. So first, we're going to talk about the first couple of steps, which is basic information about how types work in the language, how you name things, and so forth. So Ruby is dynamically typed. What does that mean? It means that objects in Ruby definitely have a type. Variables don't have a type. So that's different, for example, from Java, where if you declare a variable to be of a certain type, you can only ever assign it values of that type, and you have to pre-declare your variables. So in Ruby, this would be perfectly legal. I have the same variable that first I assign it an integer value, then I assign it a string value, and then if I assign one to the other, right, everything is by reference in Ruby. So X is this object, which is the string foo, and if I now set Y to X, what I'm actually doing is just creating another reference to that same object, which means that if I set the 0th character, and of course in computer science, the first character is always the 0th, right? We always count from 0. If I set the 0th character of Y to something else, what I've really done is change the underlying object. So the value of X is now the same thing as the value of Y, right? Because X and Y are really just handles to the same thing. Typing is also weak. What does that mean? Surprisingly, it means that types don't usually matter very much. What does matter is the behavior of an object and which methods it responds to. And we will have a lot more to say about that and some good examples when we talk a little bit later about duck typing. Okay, primitives, variables, and naming. We said Ruby is an object-oriented language, so when you define a class, the class names use upper camel case. And this is actually a syntax thing. Notice the use of the less than symbol. That's how we indicate simple inheritance. So our class bank account inherits from the account class. There's no double inheritance or multiple inheritance or anything like that. There are class variables. You might call these static variables in other languages. They're preceded by a double @ sign. Instance variables, a single @ sign, and just plain old local variables, which are preceded by nothing at all. And these are all 3 different namespaces. So you could have variables whose textual name is the same, but one of them is a class variable, one of them is an instance variable, and one of them is a local variable, and those are 3 different variables. For obvious reasons, you shouldn't normally do that because it's just plain confusing. Class variables and instance variables have class scope. What does that mean? Is that the instance variable of a class is visible to any method defined in that class. Any method can access it, any method can modify it. Local variables are only visible within the block where they are defined. We'll have a lot more to say about blocks, but if you reach back to your knowledge about anonymous lambda expressions, that's a block. Methods and variable names use lower snake case. This is not syntactically enforced, but it's basically the same as wearing the wrong color pants in public if your code is seen by other people. So technically, nothing will, the world will not explode if you use camel case to define method names and variable names, but you shouldn't because that's one of the idioms of the Ruby community. Notice, by the way, that method names can contain things like question marks and also exclamation marks. If you've ever seen Lisp or Scheme, it is not unusual in Ruby for a method that is designed to be a predicate, that to answer a question, the method name will sometimes end with a question mark. Why? Because it sends a signal to the programmer that this method is designed to do some sort of a test and make a decision as a result of the test. Sometimes methods that do a dangerous thing will end with an exclamation mark or a bang, as computer scientists sometimes call it. So, valid credit card, question mark, but maybe charge credit card, bang. It does something dangerous. It has side effects that you should be aware of. By the way, remember when you write code, you're not writing code for the computer to execute. If you were doing that, you'd write assembly language. You're writing code for other programmers who are going to look at your code weeks or months or years down the line and try to do something useful and enhance it. So anything that you can do that provides just a little bit more of a hint to the person reading the code as to what it does is usually time worth spending. Methods can be declared public or private. A public method is available from anywhere outside the class. A private method is only visible to the class itself, so things that are helpers and that don't expose behaviors of the class would usually be declared private. And finally, there's a way to do constants and globals, although generally you shouldn't. Constants are scoped to a class. Globals are scoped to the entire universe. That's why they're global. But in most cases, if you find yourself defining a constant or a global, you should rethink that part of your life because you almost never want to do that. Other primitives, symbols. Symbols are a Ruby thing. A symbol is kind of like an immutable string whose value is itself. And what that means is that if I decide to assign the symbol rails to some variable, there is exactly one instance of that symbol in the whole universe. I can't modify the symbol. I can't really do anything useful with it. I can sort of convert it into a string, and I can convert it back from a string. But usually, symbols are there to give, again, the other programmer a cue that the value of favorite framework is not something that's allowed to be just some arbitrary string. It's probably one of a fixed number of choices, similar to something like an enumeration in languages that support strongly typed enumerations. So very often when you see a symbol in a place where it looks like you're like, why isn't that a string? Most of the time, it's because the symbol is there to say, this is one of a fixed number of values that is legal, and you could go look at the documentation to figure out what the other ones are. So symbols and strings do not equate to each other. The symbol rails does not double equal the string rails, but you can trivially convert back and forth between them. Boolean expressions. This is one that trips up a lot of people. Nil and false are special values that are always falsy. What does falsy mean? Falsy means that in a Boolean expression, it will evaluate to a false thing. Truthy means it will evaluate to a true thing. And these are really terms that Rubyists use. Unfortunately, they have nothing to do with the post-fact world in which some facts are truthier than other facts. However, nil and false are the only falsy values in Ruby. Everything else is truthy. The number 0 is truthy. The empty string is truthy. The empty array or the empty dictionary or a hash, which is what Ruby calls it, those are all truthy values. Collections. This is the other big Ruby idiom. Ruby has arrays, as you might expect, but because of weak typing, the array doesn't have to have all the elements be of the same underlying type. So here's an array that's got 3 elements in it. As is typical, arrays are numbered from a starting index of 0. So in this case, x sub 1 is the string 2. X sub 4 is this, springs into existence as nil because we haven't defined the array elements out that far. So you can safely dereference an array element that was never defined, but you'll just get nil. There's also hashes. These are just the same as what Python calls dicts, but Ruby calls them hashes. So please call them that. In the hash literal syntax, where I just want to set one up, I use curly braces to indicate that it's a hash. And just like with arrays, neither the keys nor the values of the hash have to be of a consistent type. So I've defined a hash with 2 keys, one of which is a string, one of which is a symbol. And because the second key is an array, I can actually modify that array in place. Remember that every object is really just being referenced by the variable that names it. So I can sort of reach into the hash and do things to its contents. So remember, when you're defining an array in place, it's square brackets. When you're defining a hash in place, it's braces, but both of them are dereferenced using brackets, right? So an array dereference with a numeric subscript or a hash dereference that has a hash key, both of them in code will use square brackets. And you might say, well, that means that in code, you can't tell by looking at something whether it's an array or a hash when you see a dereference with square brackets. And my answer to that is, if you're at the point where you have to wonder that by looking at the code, the programmer hasn't really done their job, right? If you need to sort of be tracing back to see the value of or the type of something, and you're that deep into the code, probably the code isn't as well designed as it should be. Similarly to arrays, if you try to dereference a hash key that doesn't exist, you'll just get back nil, right? So it's always safe to try dereference. And there's also a whole bunch of other methods around arrays and hashes. Like you can ask a hash if it has a key or not. You don't have to dereference it and see if you get nil, but I'm just trying to give you the basics, not the overview of the entire language. Okay, moving right along. Strings and regular expressions. You can't live without strings. I don't think I've ever written a significant program of more than 3 lines that didn't manipulate strings. Ruby has strings. The double quoted kind, there's also a syntax %Q followed by braces as delimiters. These two are exactly the same syntactically. The reason you care about double quotes is this wonderful, wonderful thing, string interpolation. In a double quoted string, if I have hash curly braces, the expression between those curly braces can be anything. So it's not just sort of interpolating a variable in place. You can interpolate the results of any expression, and you will be amazed how often that turns out to be useful. Ruby also has single quoted strings, or the alternate syntax %q, and the difference is in single quoted strings, the variable expansion does not occur. A single quoted string is verbatim exactly what it is. Regular expressions. I will say this many times during the course. There's a handful of life skills all software engineers have to have because you're going to use them over and over and over again in every new language. Regular expressions, definitely in that category. So one way to do a regular expression match, the most common way in Ruby, is to use the equal twiddle operator. The regular expression is between slashes, which is a syntax used by many other languages that support regexes. As you know, because you're all experts in regular expressions, the trailing I means ignore case when matching. As you also probably remember, dot matches any character, unless, of course, you backslash it. Are we confused yet? We're going to go review our regular expressions. We're going to go to rubular.com and practice until you love regular expressions. And when you do that, you will come to realize that this regular expression matches 0 or more of any character, followed by an @ sign, followed by 0 or more of any character again, followed by an actual dot, followed by edu, followed by end of string. And the parentheses, as you no doubt remember, or you'll review on rubular.com, parentheses serve to capture parts of the match. So in this case, if the match succeeds, right, this expression is going to have a truthy or a falsy value. If the match actually worked, you'll get a truthy value. If it didn't work, you'll get a falsy value. And when you get a truthy value, the global variables $1, $2, and so forth are set to match what each part of the parens matched. So in this particular example, $1 would match what the first parentheses captured, which is everything before the @ sign, which is Fox. And the second group would capture everything up to the .edu portion. So in that case, that would be Berkeley. Again, if you don't remember this from regular expressions before, don't worry. You're going to get a lot of practice with them, more than you want. When I say the value of the match, this is one of these things that I want to soak in, right? This is in the category of, if you remember nothing else about Ruby, remember this. Everything in Ruby is an expression. Everything. Every statement has a value. An assignment statement has a value. So in this case, the value of the statement is truthy or falsy, depending on if the match actually succeeded. As a side effect, if the match succeeds, you get these variables set up for you, but that's not the value, right? Everything in Ruby has a value. Even functions have a value, even if you don't have a return statement anywhere in the function. And we'll have more to say about that when we talk about functions next.